While conducting evaluations, it is important for researchers to have enough data to answer research questions without having to query the entire population, which demands a lot of resources and time. This is where sampling comes in. Let us define it and understand its purpose in this module. Sampling is the process of selecting a portion of a population to represent the whole population in statistical analysis. It is used to collect data from a large population in an efficient and cost-effective manner without having to study the entire population. Some of the key considerations during this process include sample size and representativeness. Sampling process is of two types: probability sampling and non-probability sampling, which we will now discuss. Probability sampling is a method where each unit in the population has a known and non-zero chance of being selected. This method is suitable for inferential statistics and hypothesis testing, and its results are representative of the populations and unbiased. It is easy to analyze and generalize, but this method has certain disadvantages. It is time-consuming and complex and requires a complete list of the population. Some of its examples include simple random sampling, systematic sampling, stratified sampling, cluster sampling, etc. Now we have non-probability sampling, a method of sampling where the chance of a unit being selected cannot be accurately determined. Its use is limited to inferential statistics and is often used in exploratory research. This method is quick, easy to conduct, flexible, and suitable for hard-to-reach populations. But the results derived from this method may be biased, not representative of the population, and difficult to generalize. Some of its examples include for convenience sampling, quota sampling, snowball sampling, judgment sampling, among others. Something called the sampling and non-sampling error. A sampling error occurs when a researcher chooses a sample which is not representative of the population. On the other hand, non-sampling error refers to errors other than the sampling, such as error in the estimation. There are ways to mitigate such sampling errors, which include analyzing the sample in the planning phase, execution phase, as well as the analysis phase. Sometimes, despite adopting all these steps, it is difficult for researchers to remove sampling bias, which occurs when some members of a population are systematically more likely to be selected in a sample than others. For example, to analyze the voting patterns for presidential elections, if you poll 1,000 middle-class, blue-collar voters, the sample will be heavily biased because it won't be diverse enough to paint the whole picture. Now, there are different types of probability sampling based on different requirements: simple random sampling, systematic random sampling, stratified random sampling, and finally, cluster random sampling. Let us describe each one of these briefly. First up is simple random sampling. This is a type of sampling in which the researcher randomly selects a subset of participants from a population. Each individual has an equal chance of being selected. Next is systematic random sampling. It is a probability sampling method in which a random sample is selected from the population with a fixed periodic interval. The periodic interval, which is also known as the sampling interval, is calculated by dividing the population size by the desired sample size. Third is stratified random sampling. It involves the division of a population into smaller subgroups known as strata. In stratified random sampling or stratification, the strata are formed based on members' shared attributes or characteristics, such as income or educational attainment. And finally, we have cluster random sampling. In this method, you need to divide the population into clusters, such as districts or schools, and then randomly select some of these clusters as your sample. The clusters should ideally each be mini representations of the population as a whole. Let us now discuss non-probability sampling. There are 4 kinds. Convenience sampling, which includes the individuals who happen to be most accessible to the researcher. Second is voluntary response sampling. Here, instead of the researcher choosing participants and directly contacting them, people volunteer themselves. Then we have purposive sampling, which involves the researcher using their expertise to select a sample that is most useful to the purposes of the research. And finally, we have snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. The number of people you have to access to snowballs as you get in contact with more people. To select a sample for monitoring and evaluation, it is crucial to understand each step in the process, which is what we will do in this section. First, you must define the purpose of monitoring, which basically means to determine the specific objectives of the monitoring evaluation. Then you must identify the key metrics or indicators that are relevant to the monitoring evaluation. These may include performance measures, quality standards, or other relevant criteria that align with the objectives of the monitoring. After identifying the indicators, you move on to determining the sample size. For this, consider the appropriate sample size based on statistical principles. A larger sample size generally provides more reliable results, but it may also require more resources and time. Select a sample size that is statistically significant and appropriate for the level of accuracy desired. Next step is to clearly define the boundaries and characteristics of the sampling frame to ensure that the sample is representative. After determining the sample size, it is crucial to choose a sampling method that is appropriate for your specific monitoring evaluation objectives and sampling frame. Although you have decided on the sampling method and size, you have to be mindful of potential biases that may affect the sample selection process. Then, you must document the sample selection process. Keep detailed records of the sample selection process, including the sampling method used, the sample size, and any considerations or adjustments made. Finally, you must conduct the monitoring evaluation. Once the sample has been selected, collect and analyze the data according to the defined metrics and objectives of the exercise. The sample size of the research is not a rule of thumb. Rather, it depends upon a host of factors such as the objectives of the study, availability of resources, sampling error, size of the sampling subgroup for which data has to be collected, and heterogeneity of the universe. The calculation of sample size depends upon some key factors, which include significance, the likelihood that the measured effect did not occur by chance. Significance level is denoted by alpha, which is the type 1 error. Power, the likelihood that when a program or treatment has an effect, you will be able to distinguish the effect, which is type 2 error. The loss of effectiveness by using cluster sampling instead of simple random sampling is the design effect. The design effect is the ratio of the actual variance under the sampling method used to the variance computed under the assumption of simple random sampling. The formula on screen denotes the design effect. Then we have the margin of error, a percentage that tells you how much you can expect your survey results to reflect the views of the overall population. The smaller the margin of error, the closer you are to having the exact answer at a given confidence level. Now that we know the estimation of sample size and the key criteria associated with it, let us take a look at how to do so. First, we must define the objectives of the survey and determine the population. Then, we must select the appropriate sampling method, after which primary sampling units need to be determined. The next step involves obtaining the sampling frame, which includes a list of all the sampling units. Then we need to decide the sample size, after which we execute it.